Hi, this is Luis, and today I'm going to show you my final project for the Interconnected Devices course. For the course, I built an IoT sensing interface. So let me go over the main characteristics of the project first before I show you the actual circuit. So what I built is a small circuit that can be integrated to other pieces of equipment. And the purpose of this circuit is to acquire two different types of analog variables. In my project, I used a temperature sensor and a light sensor. The circuit also includes an LCD display, okay, through which you can see the current value for those two variables, temperature and light. And these variables can be calibrated in the Arduino program that I wrote in C, so that you can show the value of those variables in different scales. So for example, in the case of the temperature, I am showing the temperature in both Celsius and Fahrenheit degrees. Okay. Now, the reason why I built the circuit is because it can be easily modified in order to include other types of sensors. I can replace the temperature sensor with, let's say, a pH sensor or a humidity sensor, okay, so that I can just have other types of reading depending on the real life application I want to implement this on. Okay. Okay, so now that I went over the main characteristics of the project, let me just show you the circuit so that we understand how the device works first. Um, it's a very simple circuit, as you can see. It has a source of 5 volts DC, which I take from the Arduino directly. And it includes an on-off switch, okay, for power. So when the switch is in the on position, the user will know that the system is powered up because a green LED will turn on here, okay, and also the LCD screen will turn on. Okay, speaking of the LCD screen, it has a knob in the circuit. It's actually a potentiometer that allow us to regulate the contrast of the numbers on the screen. Okay, and there is a second switch. This is actually the sensing part of the circuit. This second switch allows me to select the mode in which the device is going to work. In one position, I can make it work in temperature mode. In the other position, I can make it work in light mode. So when the switch is in the temperature mode, the temperature sensor will register, it will acquire the temperature from the environment, okay, and send it to the Arduino via the analog input 0. The user will know in this case that the system is in temperature reading mode because an amber LED light will be on, okay, in this mode. And if the circuit is working in light sensing mode instead, a blue light, a blue LED light will be on to indicate such condition. In the case of the light sensing mode, a voltage divider will allow me to send the readings from the light sensor, okay, which is a photoresistor, to the Arduino via the analog input 1. Okay, I have also implemented some alarm conditions in the project. Okay, and that's why I included a red LED light here and a buzzer as well. That well, the buzzer will beep intermittently, and the light will actually flash. The red light will flash whenever one of those conditions, one of those alarm conditions, are triggered by the program. In the code I implemented, two alarm conditions. The first one is when the temperature is too high, all right? And the second one is when the light is too low, okay? The specific set point can be changed in the program, of course, very easily, okay? But that is simply what these two actuators do. They will just indicate that there is an abnormal condition, okay, in the environment that we are sensing these variables from. Also, even though it's not depicted here, I'm using an Ethernet shield in order to send a Twitter message to a user, okay, whenever one of these conditions occur. So whenever there is an alarm, whenever there is a condition that is not normal, then the little IoT device will send us a Twitter message informing us of such event. Okay. So now that we went over the circuit schematics, let me show you the actual circuit that I built. Okay, so that we can just compare the components I showed you on the circuit schematics with the actual circuit. So in here, let me see if the angle of the camera helps me. All right, you can see the two switches I mentioned in the previous part of this video. You have the power on switch, which is this one here. You have the mode switch. This is the one that will select the type of variable we want to measure, temperature or light, this one here. Okay. You can actually see here the potentiometer, this one here. Okay, it's the one that controls the contrast for the LCD. Okay, which is here. The system is off, by the way, right now. That's why you cannot read anything. And you have here the buzzer, okay, a buzzer, and the red light that will blink in order to indicate if there is an abnormal condition. And in the last minute, I just placed one more switch in here. This is just to mute the annoying beeping sound from the buzzer, okay, so that we can proceed with the presentation, okay. What else? As I said, we have the LCD here, okay, the Arduino right there. You can see it has the the Ethernet shield already on with the RJ45 connection, you know, and the Ethernet cable connected already. Okay, and you can see also all the LEDs that this circuit comes with. So I have the green LED light here, okay, which indicates the power on condition of the circuit. I have an amber LED here, if you can see because of all these cables. Okay, an amber LED here, okay, that indicates that the system is in temperature mode, temperature reading mode. You have a blue light here, okay, that indicates the system is in light reading mode. Okay, so let me just power up the circuit just to show you how it works. So let me turn on the system now. Once again, the power switch is here. Okay, so you can see now that the system is showing me a green LED light, showing me that the system is on. And actually this switch here, okay, is flipped to the light reading mode. That's why you have the blue LED, very bright, by the way, on in that part. If I switch this power switch, that's off, and that's on again, okay? And if I flip the other switch to the other side, now the system is in temperature reading mode, and you can see, or the user can actually identify in which mode the system is working because the light will be different. Blue for light, amber for temperature. So let's go to the to the LCD now, and you can see in here that the LCD shows me the temperature in actually two scales. In Celsius, it is 22.22 currently in this room, and in Fahrenheit degrees, 72. Okay, degrees. All right. If I switch this, okay, and it's in light reading mode now, you can see how the LCD shows me also the new values or the values for the new variable. In this case, it says light condition. It's 239 or 240 out of 255. Of course, in order to calibrate light values, I would have to use another standard device in order to measure luxes or lumens, which is not, it is out of the scope of the project. So in this case, I just decided to use a percentage scale from 0 to 255. In this case, we are at 241 out of 255. Okay, and now let me just create an alarm condition. So let me just put my finger over the light sensor, like this. And you can see that the red light is blinking there, and you have actually the buzzer making this kind of annoying sound. So what I'm going to do is I'm just going to disable with a little switch the buzzer. So the buzzer has been disabled now. So let me recreate the alarm condition now without the noise, without the sound. I'm going to just remove this lamp for now and put my finger here. Okay. And you can see how the light is flashing now. The red LED light is flashing. Okay, if I remove my finger, okay, the low light condition is removed, so that is read by the Arduino, and now the LED, the previously flashing LED light is not flashing anymore. Okay, so now let me just show you how the user can debug some of the conditions using the serial monitor. Okay, and finally, just let me go over the software part of the implementation. On the left side of the screen, you can see the actual Arduino program, which I wrote in C language. Okay, it's a program that has about 136 lines, so it's not that long, it's not that complicated. Okay, and on the right hand side of the screen, you can see that I have this other program called Terminal. It is actually serial communication emulator. I can always use the serial monitor that comes built in the Arduino IDE program, but I will show you this one instead because I find it more interesting. It has a couple of features that I really like. So let me just upload once again the program to the Arduino so you can show that there are no error messages down there. Okay, it's uploading right now. And once it's done, what I'm going to do is I'm going to start the terminal, okay, which you can see here. It's going to communicate via COM port 3. So down here, okay, so that is fine, no errors on the IDE. So it uploaded our code correctly. And now let me just do this. I'm going to maximize this. All right, and I'm going to just connect. Okay, so it's establishing the communication via serial. Okay, the serial port. Okay, and now you will start seeing the values that the system is acquiring in real time from the actual device that we built. So in here you can see it says uh, right now the system is in temperature mode. So it's reading temperature, and it says the current temperature is 21.22 Celsius degrees, 72.00 Fahrenheit degrees, or 70.20, well, changing, 70.20 Fahrenheit degrees. Okay, so now the nice thing about the serial communication part here is that, let me show you this. This tool has, among other nice features, it has a graphing application. I didn't include any scale yet, but you can just you can see in real time, the values that you are acquiring, and also I found that you can do some logging. Okay, I will show you the logging in the end. But let me just play with the Arduino first. I'm gonna change the current mode of the Arduino to light reading mode and see what happens on the screen. So here. So now you can see here, it says now the current light condition is 200 out of 255. So it actually detected that the Arduino is working in light sensing mode now. Now let me create a condition, an abnormal condition that triggers our alarm. So I'm gonna just do this. I put my finger there. You can hear the beeping sound again, right? And you can see on the screen it says the current light condition is poor light condition detected, sending alert now, and it shows you the actual reading. So in this case, whenever the light goes below 50% of that scale, 0 to 255, that is going to send an alarm. And at the same time that this is happening, a Twitter message is being sent to my Twitter account, informing me that an abnormal condition has occurred in the environment that we are trying to supervise or control. Okay, so that is very nice. Now, let me show you why I included this on-off switch at the beginning of the circuit. Let me just turn the system off. Okay, switch is off now. And look at that. It says data acquisition system is currently off. Okay. Last but not least, let me show you the last thing that I did with this one. As I said, I created a log. So if I stop the log now and I go and open the log here, look. So while we were acquiring all those values, I actually acquired a log that I can use for historical data analysis purposes. So this system can be actually tweaked very easily